In this video, we're going to go through the composition of functions, where we'll be composing f composed with g of x and g composed with f of x. So here we see that we have an f of x of x plus 2 and a g of x of 4 minus x squared. And so our first equation is f composed with g of x. So that means that we are going to take, and we're actually just evaluating those, but we need to form it first. So to do that, we're going to take our f of x, and where there's an x, we're going to leave a space. And then inside of that, that's where we're going to put our g of x. So 4 minus x squared. And then we can write this out so that our f of g of x equals a negative x squared plus 6. And we are evaluating that. It looks like at the numbers 0, oops, and we're going to be evaluating that at the number 1, if those are possible. So we're going to go ahead and set it up. Squared. So notice that I'm removing the x, and that's where I'm going to put my values. And so for f of g of 0, I'm going to get a 6. And for f of g of 1, we're going to get a 5. So we would write f of g of 0 equals 6, and f of g of 1 equals 5. And so there's those two answers. And now we're going to compose it the other way, which means now we're going to write our g, and when we come across our x, we're going to leave our break there, and that's where our f of x is going to go. So this is saying that f goes inside of g, and back here we're saying that g goes inside of f. So here we're going to write down x plus 2. Now notice that this time, because we have this x plus 2 quantity squared, we're going to need to distribute that. You might know that as foiling. And so when we FOIL that, or when we distribute that out, that gives us an x squared plus 4x plus 4. So now we have 4 minus x squared plus 4x plus 4. And then we will need to distribute that negative sign. And that's going to give us 4 minus x squared minus 4x minus 4. And when we simplify that, that's going to give us our g of f of x is equal to a negative x squared minus 4x. And then from here, we're evaluating that at the number 0. And we're going to evaluate that at the number 1. So we'll set it up. And we know that we're going to put 0 in each of our x's spots there, giving us an answer of 0. And plugging in a 1 here. And that's going to give us an answer of negative 5. And so then we'll just need to write that as g of f of 0 equals 0, and g of f of 1 equaled negative 5. We are also going to practice finding the domain of composition functions. So we'll move on, and here we're going to see that we're being asked to find the domain of the composition of f of g for the functions f of x equals x squared minus 9 and g of x equals the square root of 9 minus x squared. So we're going to begin by finding the domain of each of our functions. So our domain for our f of x, because it's a polynomial, should be x can be all real numbers. And for our g of x, our domain, well, we know that because that's a square root, that the inside of that square root must be a 0 or larger. So we need to know what number will make the inside turn into 0. So we know it can be no bigger than that. So we're going to go ahead and we're going to take our 9 minus x squared and set that equal to 0 so that we can solve. So we're going to add x squared to both sides, get 9 equals x squared, square root, and we'll see here that x is a plus or minus 3. So that tells us that our domain for x, for g of x, must be between -3 and 3. So that is definitely more restrictive than our domain for x. So let's go ahead and do our composition now. So our composition, we write down our x, our f of x rather, and leaving the x blank, and then inside of there we'll write our g of x. So square root of 9 minus x squared, and because we have a square root and a square, those will cancel each other out, and that's going to leave us with a 9 minus x squared minus 9, which will be a negative x squared. So here is our f of g. Well, let me write that a little bit better. And so our final answer for our composition of f of g, or f with g of x, is negative x squared. And our domain is going to be the most restrictive domain out of our f of x and our g of x. And so our domain for our composition is going to be one such that x must be between or equal to our -3 and our +3. And we can write that in the following set notation: -3, 3. Either way is correct.